Welcome back. We are going to continue in exploring measures of variability, and we're going to be focusing on calculating the standard deviation. So by the end of this video, you should be able to calculate the standard deviation of a data set, and then you should be able to interpret what that standard deviation means. So when we're calculating the standard deviation, okay, one of the things we want to keep in mind, right, is that it's going to be larger than the mean absolute deviation. And you may say, well, wait a second, why would it be larger than the mean absolute deviation? Well, if you didn't come up with it on your own yet, it's because you're squaring them, right? So any value that falls far away from the mean, like an outlier, will have a significantly larger impact, okay, on the standard deviation than it does on the mean absolute deviation. So let's look at the steps to calculating the standard deviation, right? That's really the focus of what we're trying to go through today. What's really nice, right? We're going to just use that previous example that we looked at from the White Sox, okay, under manager Ozzie Guillen when he complained about the consistency of, right, his team. And so the first two steps are actually the same exact first two steps that you take for calculating the mean absolute deviation. Okay, so we're going to go ahead and we're going to calculate that mean. So we're going to add those values together and then divide by the number of numbers. Okay, and when we do that, we get that our average is 5.3. So that's step 1. Okay, moving on to step 2, we're going to find the deviations from the mean. So we just simply take each value, right, and we're going to subtract that mean from it. So take each value, like 4, we're going to subtract the 5.3, and that gives us our deviations, which, as we talked about before, right, if you add all those up, they give you 0, so it doesn't really help you. So you have to do something with it. And what you have to do with it is square each one of those deviations. So if you go ahead and you go through and you square each deviation, obviously we're going to get positive values now. And you can already see how much larger these values are than just simply taking the absolute value. In particular, if you look at the 12-run game, right, that's 45. That is a massive amount, right, larger than what it was before of just 6.7. Now is where it gets a little crazy, okay? So we're going to take the sum of all those squared deviations, and then we're going to divide them by the number of observations minus 1. Okay, so we'll show you exactly what that looks like on the next slide. Okay, so we're going to take all those values, 1.69 plus 10.89 plus 1.69 plus 0.49 plus 0.09, right, so on and so forth, all the way to the end. Right, we're going to add all of those together, and then we're going to divide it by 1 less. So there are 10 observations, so we're going to do 10 minus 1, okay, which gives us 9. So when we do that, right, we get our standard deviation equals the square root of 82.1 divided by 9. And when you do that, you get that that's approximately 3.02 runs allowed. Okay, so that means that the White Sox defense performance typically vary from their ability by about 3.02 runs. Okay, and as I said at the beginning, right, we notice how much bigger that outlier of 12, right, bigger that impact is, right, than it was for the mean absolute deviation. Okay, when we add all these together, it adds up to 82.1 and 44.89. So over half that value comes from that one big outlier. Okay, so standard deviation is affected by a much larger amount, okay, by those outliers than what the mean absolute deviation is. And remember, just like with the mean absolute deviation, the smaller the number, right, the more consistent the data is. Okay, so the smaller the number, the more consistent it is. So when we're comparing two different standard deviations, whichever one is smaller gives us the more consistent, okay, group. So whether that be you're comparing two hitters or two teams or whatever you're comparing, right, the smaller the standard deviation, the more consistent they are. Hopefully you learned how to calculate the standard deviation. Obviously, if you have any questions, make sure that you let me know and you ask. And hopefully you had a wonderful time and good luck on your problems tonight.